This is the third video for electricity part 2, and we're going to talk about the concept of resistance. And this is how much a material slows down the flow of electrons. So resistance is how much a material slows down the flow of electrons. Okay, so things like insulators, dry wood, ceramic, that electricity does not flow well through, they have high resistance. Things like metals that we use to conduct electrons, they have low resistance. And the unit of resistance is called the ohm, okay, named after Georg Ohm, who actually was a high school science teacher. Okay, and so that is the ohm, and its units are volts over current. All right, so 1 ohm here is 1 volt over 1 amp. All right, and if we look at two examples, what would resistance depend on? If we have a huge tube here and a small garden hose, we can kind of predict that the garden hose is going to have more resistance. Let's say you have a long garden hose which has a small cross-sectional area and a huge tube that is short with a large cross-sectional area. So resistance should depend on one, something like the type of material, which we talked about, insulators versus metals. 2, it should depend on the length, and 3, it should depend on the cross-sectional area. And you'll note that high voltage power lines are very thick. They have a large cross-sectional area, so they can transmit a lot of current with low resistance. And the formula for resistance R, which it would be in ohms, is P here, and P is the resistivity of material. And this is a super fancy way of saying the type of material. So things with low resistivities, silver, copper, these are metals that conduct electricity. Things with high, like wood or ceramic, these are insulators that do not. And this is simply the length of something divided by the A, where here A, and actually here, sorry, I said it was amps. This is actually cross-sectional area. So we'll say X sectional area, which is in meters squared. Okay, so resistance, how much a material slows down the flow of electrons. It's measured in ohms. An ohm is a volt over A, and in this case, it's the cross-sectional area, and resistance depends on the type of material, which is P there, the length of the material, and the cross-sectional area of the material.